Hello again. This is Lab 2, Part 2, which is the parallel combination, the parallel circuit, parallel resistive circuit. And here, again, I show you the circuit diagram, which shows how the battery is connected to the two resistors in parallel. The two terminals here are connected to each other. The two terminals here are connected to each other, which allows for R1 and R2 to be in parallel. And the verification of Kirchhoff's current law should show that the total current coming out of the battery should equal to the sum of the current through R1 and the current through R2. Again, following the circuit diagram, not just the pictures of the video, we can see here that I have the 5 volts connected to one resistor and the same 5 volt through this wire connected to the other resistor. That means they're connected to each other. And of course, you see here they're connected both to the blue line, which is the negative of the power supply. And that means these two resistors are in parallel. Of course, this again, R1 is 980 ohms, R2 is 217 ohms. And I added 2 green wires here sticking out because I want to show you how to use that to measure the current by inserting the ammeter in the path of R1 and later in the path of R2. For the voltage, obviously I'm just going to verify that the voltage is the same everywhere. So in this case, through R1, obviously I forgot to have the power supply on, and I'm using a power supply, not the battery. So in this case, it's 501, 501, and of course, the battery is 501. So that means in parallel, they all have the same voltage. Like in series, they have the same current. In parallel, they have the same voltage. Then I'm going to turn this into an ammeter. And I'm going to use the 20 milliamps. I think I'm going to go to 200 because at least 2 currents are going to exceed the 20 milliamps. So I would lose resolution in one of the currents, but just to keep it simple, I'm going to leave it at that range. So in the case of the current through R1, I'm going to disconnect R1, as you see here. And I know that the current is going to be positive going from the green wire, which means where the resistor was connected to the resistor. So now it's in series with the resistor. And the measurement says it's about 5.1 milliamp or so. Taking it back, putting it back in the circuit, break the connection to the other resistor, inserting the ammeter in series with that resistor. And the current is about 22.9 milliamps. And we will see that as in this case, I could just remove the green wires, right? I remove this connection, and then this is from the battery to the parallel combination, and that's the total current, and it's about, let's see here, it's about 27.9 milliamps. And these are supposed to be the measurements that will allow you to correlate the calculations with the measurements. Just to show you a multisim version of it, obviously in this case, the power supply that I used was 4.97 volts. In your case, just as a reminder, for the lab report, when it says calculated values, do not use nominal values for the known entities. For example, the battery should be whatever the battery you decide is as measured. The same thing with R1 and R2. And in this case, then when you compare, you will see that the comparison will give you values that will be very close to what the calculated value should be, what the measured values should be, and what the simulated values will be. Of course, simulation is not part of the process right now. I'm just showing you ahead of time what you will learn next week, right? When you use multisim to get one step closer or very close to what the measured values would be by using multisim, right? In the meantime, this is what the numbers are, but you decide for yourselves. You decide. If you have your components, you can make your own measurements. If the whole group is online, you can use whatever numbers that I have provided in this video. But the most important part is that when you decide how to fill out the tables, it's the observations that you make. It's the presentation of the topic, the presentation of the results, and whatever you learn from it and whatever you can teach others. That's the most important part of a lab report.